Okay guys, this is 5.2 for Algebra 2, solving a quadratic by graphing. So, quadratic equation looks like that, ax squared plus bx plus c, where a, b, and c are going to be numbers. So a quick example would be something like 4x squared minus 7b plus 2 equals 0. That would be an example. Sorry, this should be x. So that would be a quick example of a quadratic equation. Now, when I graph a quadratic equation, one of three things can happen. What I'm really looking for is where does it cross the x-axis? That is what is considered a solution. So one of three things can happen. I can touch it once, which is what you have on the left-hand side. I can touch it, cross it twice, which is what you have in the middle. Or I can never touch it. And if that's the case, then we call that no real solution. We'll talk about what's an unreal solution later. So one real solution, which means it's going to come down, touch, and take off again. Two real solutions, it's going to cross it twice. No solutions, it never crosses the x-axis. So if we take a look here, x squared plus 6x plus 8 equals 0. So kind of thinking back, the x-intercept, once again, x is 0. So the y-intercept is going to be just 8. The vertex, the axis of symmetry, and the 0. So if we look, remember how to do the axis of symmetry. That's at negative b over 2 times a. So in this case, a would be 1, b would be 6, c would be 8. So that's going to be negative 6 over 2 times 1. So my axis of symmetry is going to be at negative 3. So negative 3. My y-intercept is at 8. So that's going to be about up here. My axis of symmetry is going to be right there. So that means on the other side, if I reflect it on the other side, about 8 should be right there for that one. So somewhere on my axis of symmetry is going to be where my vertex is. So now, if I put my axis of symmetry in for x, I'm going to get 9 minus 18 plus 8 equals 0. So that's going to be, or not equals 0, that's going to be negative 1. So that means that the vertex is going to be at negative 3, negative 1. So at negative 3, negative 1, there's my vertex. So now remember, the traditional basic quadratic graph goes up 1, goes over 1, up 1, over 2, up 4. And then reflect that. So where does it cross the x-axis? Well, it crosses twice. It's going to cross at negative 2 and at negative 4. So there is my solutions to that one. So this one, right now it's not in standard form, so I've got to make it in standard form. I've got to bring the 16 over, make it equal 0. And I've got to put it in the order that makes sense for me. So that'd be negative x squared plus 8x minus 16 equals 0. All right, all I did was rearrange it, bring 16 over. Hopefully that's not too tough for you. A is going to be negative 1, B is going to be 8, C is going to be negative 16. So my y-intercept is going to be at negative 16. All right, my vertex, actually let me back up. With a negative in front, I'm hoping you guys will start to recognize that wherever I graph this, it's going to be opening down. That's what that negative out front means. So figuring out the axis of symmetry, negative b over 2 times a, that's going to be negative 8 over 2 times negative 1. So that's going to be positive 4. So my axis of symmetry is going to be at positive 4 right there. So now throw positive 4 back in there and see what happens. So I get negative 4 squared. This is actually going to become a negative answer, whatever I get, plus 8 times 4 minus 16 equals 0. So this becomes negative 16 by order of operations plus 32 minus 16. And that actually does equal 0. So that means at negative 4, 0, that's where my vertex is. My axis of symmetry is at positive 4. My vertex is going to be at 4, 0. So my only 0 here is going to be 4 because this is going to open down like that. So once again, I take a look at one like this. A is going to be -1, B is going to be 4, C is going to be -1. So my y-intercept is going to be at -1. So my y-intercept is going to be right here. So my axis of symmetry, -b over 2 times a. Hopefully you guys are starting to recognize this right away. -4 over 2 times -1. So that's going to give me +2. So my axis of symmetry is going to be at 2. Right there. Get in that habit of drawing that little line just so you kind of have an idea of what you're doing. So now -2 squared plus 4 times 2 minus 1. That's going to be -4 plus 8 minus 1. So that's going to be a +3. So my vertex is going to be a 2, 3. So right there. The negative out front tells me that I'm going down. So I'm going to reflect this over here. So I'm going to go over 1, down 1, just like that. So remember, it goes over 1, down 1, over 2, down 4, over 1, down 1, over 2, down 4. Sorry, it's a little bit more than that. So my zeros end up being at about 1/2 and about 3 1/4. So you go about +1/4, +3 1/4. All right, word problems, everybody's favorite. Here we go. Adrian Nicholas broke the world record for the longest human flight. He flew 10 miles from a drop point in 4 minutes, 55 seconds using an aerodynamic suit. Using information from the diagram and ignoring air resistance, how long would he have been in free fall had he not used his suit? Use the formula -16t squared plus h of o, where h is the time in seconds and the initial height h0 is in feet. So number one mistake kids will make is they'll do this, -16t squared plus 10, and they'll try and look at that. Slight problem. He was 10 miles above the Earth, and this is in feet. So this is not going to be the correct one. I don't want this. I want -16t squared, and I want 10 miles times the number of feet in a mile, which is 5,280. So it's 5,280 feet in 1 mile. So in 10 miles is going to be 52,800 feet. So here is my graph. So I want to figure out, where does this thing equal 0? Well, I got to figure out kind of where does this thing equal 0. So on a graph, just kind of a quick sketching of a graph, my y-intercept is 52,800. And so I kind of want to figure out, where would he have hit the ground without his suit? That's kind of what I'm looking for. All right, so our question becomes, how do we graph this? Well, I'm not going to graph this by hand because that would take too long. I want to use a calculator to do it. So here's what I'm going to do. All right, I'm going to bring this over right here, and I'm going to put this in for y1. First off, I'm going to make sure my stat plot is off. It is good. So I'm going to take -16x squared plus 5,200 or 52,880. So this is what's going to graph. Now, if I just keep it as my regular window like that, nothing is going to show up. All right, that's because my scale is completely outside of where I'm looking. So what I want, though, is to kind of think about this. X is my time. All right, that's how long it takes. So I'm not starting at a negative time, and it's going to be in seconds, so it's going to be it's going to be quite a few seconds. So if regularly he dropped 10 miles and it took him 4 minutes 55 seconds, so maybe 3 or 4 minutes wouldn't be a bad place to start. So 3 minutes, that's 180 seconds. So let's go for that, and let's make each one like 20. So y minimum, well, y minimum 0 is where we're looking for, because that's where you would hit the ground, and my height is going to be 52,880. So let's go Let's go something like, I don't know, Y scale of 50 or something like that. Let's see what comes up. Okay, so this is representing him falling to the ground. Okay, so this is him without anything like that. So if at 90 seconds he is 76,000 past that. So what I can do is scroll back until I see y equal to 0 and see where I get. So he's right there. So at 53 seconds he's still about 7,000 feet in the air. 55 seconds he's still that height. 57 seconds he's only 77 feet in the air. So if I go one more, at 59 seconds, he's way past the ground. So I can guess to be about 57 seconds, but I can also be more exact than that. So if I use the calc button on the calculator, right up here, you go second trace. All right, it will calculate your 0 for you. If you go to 0, like that, it will say left bound. So you kind of set a left side border, right bound, and all you got to do is go to when y is negative. And what you've told the calculator to do is this. You said look for a 0 in between the two arrows that I just put. So if you go to the left side of it and the right side of it and click guess, yes, that'll tell you how long it took him to fall. It was taken 57.489. So what's my answer? My 0 is going to be 57.489 seconds. That is going to be how long it would have taken him to fall. So the highest bridge in the U.S. is the Royal Gorge in Colorado. The deck is 1,053 feet above the river. Suppose a marble is dropped over the railing from the height of 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water, assuming there is no air resistance? So once again, we're using negative 16t squared plus 10,053 plus the original 3 feet above the deck. So it's really going to be 10,056, and you're trying to figure out when is that height going to be 0. So again, I'm going to go back to the calculator and let the calculator do this for me. So I'm going to change this negative 16x squared, where x is my time and my answer would be my height, and that's going to be 1056. Delete 1056. I like that. All right, so now we got to go back and mess with the window a little bit. All right, it's not going to take up to 3 minutes. I'm guessing it's probably only going to take less than 1 minute. So I'm going 60 seconds just to start, and I'll let each one be 10. My original height is only 1056, so I can say that that's 1056. Or, I could say, let's just go 1100. And let's see kind of what that graph looks like right now. All right, so it's not even going to take 60 seconds here. So I can trace it, or here we go, second calc. Look for the 0. So my left bound, so when x is 30, it's already negative 13,000 feet. It's already hit the water. My left side is where I need to make it positive. So we're still looking at, so it's not going to take very long at all. We're looking at, so at almost 7 seconds, it's still 267 feet in the air. So I'm going to use that as my left bound. So now I'm going to go down to where it's negative. So at 9 seconds, it's already in the water. So it's got to be somewhere between 7 and 9 seconds. Guess, yes. How long is it going to take? It's going to take 8.124 seconds to drop that marble and have it hit the water. That's all I got. Use your calculator, but know what your calculator is doing and start thinking about these.